first, let's talk about the sum of the first n terms of a GP. Remember the sum of the first n terms of an AP, how we did it? We wrote the terms from the beginning to the end, then we reversed it, right? In this case, it's similar. What are the terms of a GP? A
plus R.
A plus R, no. AR, not A plus R. We multiply. Good. A, yes. AR squared, AR cubed, and the last term will be?
No, last term is
L.
No, in terms of ARN minus 1 in that form. Okay, so let's write for the GP AR squared ARN minus 1, because there are n of this, right? Okay, which has n terms. Sn will be A plus AR plus AR squared, of course, plus AR cubed. It continues up to ARN minus 1. Okay? This is equation 1. Rather than, what did we do in the other one? We reversed, right? Reversing it doesn't really help us here. So we multiply this by R. Okay, multiply equation 1 by R. Then what do we have? Tell me, everybody. Multiply equation 1 by R, what do we get? No. SNR, RSN, yes. We are multiplying the entire equation. You are giving me only one side. Yes. AR squared, AR cubed, AR to the power 4, it continues, then this times
RN
ARN
RN minus R.
minus R.
No,
Sure?
Wait, no.
I think it's just ARN.
Just ARN. You had ARN minus 1, then times R. This is power 1.
Oh,
So that's ARN minus 1 plus 1, 0. So it's just ARN. Does that make sense? So we're going to call this equation 2. Then we're going to subtract equation 1 minus equation 2. We're also going to do equation 2 minus equation 1. We're going to get two different formats, and I'll tell you the difference between the two formats. Let's put that here. So first, let's do equation 2 minus equation 1 gives, so equation 2, let's write that at the top, RSN equals, now because this is AR, everybody listen, this is AR here happens to be the second term, right? Okay, so I'm going to rearrange it such that I leave a space for A. So I leave a space for A, or I can just say 0A, because A is not there, A term is not there. The first one here is AR, am I making sense? Followed by AR squared, followed by AR cubed, alright? I don't need to write AR to the power 4, everything is within these three dots. Okay, and the last one is what? ARN. Now, between this and this, which one is a further term? ARN. So, before this, what do you have? ARN minus 1. So, I'm going to do that just to make my cancellation easier. Then, equation 1, Sn. Do I have A? Yes. AR squared, can you see? AR cubed, and the last is ARN minus 1, and this is 0RN, sort of. Okay? Because it's a missing term, so we just put 0 ARN, something like that. Because it's a missing term. Am I making sense?
Yes.
So we're going to subtract this, because that's what the instruction is. So when you subtract this, you get RSN minus Sn. I expect everyone to look at what I'm doing and not just copy. What is the first one here? negative a. What about this?
Nothing.
0.
Nothing, plus arn. Yes?
Yes.
Okay? So, this becomes Sn. So I have r minus 1 Sn. Agree?
Yes.
So I rearrange this, because this is negative, I write it as the second term. So arn minus a. Do you agree with that?
Yeah.
So, can I factorize now? This one.
Take A.
R minus 1 Sn. A can be factorized. Yes?
Yeah.
So finally, our sum is a r to power n minus 1, not minus 1 as a power, divided by r minus 1. Understood? So this is one way. The other one is the same, just that they change position. So 1 minus r, then 1 minus rn. And that's what happens when we do 1 minus 2 instead of 2 minus 1. Why do we have different ones? We'll see. So let's do the second first. Let's do this together. Similarly, if we do equation 1 minus equation 2, this is what it gives us. So we're just going to change what we have written above. Let's do that together quickly. What do I have first? Sn,
Equals
yes,
A plus AR.
a plus ar,
Plus
squared.
AR squared.
yes, plus
Plus
ar squared,
Plus AR cubed.
plus ar cubed, up till ar n minus 1,
Plus
0, right? So the missing one, I still put that because it does not exist. So that's why 0 is the coefficient. Then the second one is
8.
rsn.
Equals 0.
That's 0a
Plus
Plus AR.
plus ar,
0.
ar squared,
AR cubed.
ar cubed, up till
AR.
ar n minus 1, arn. Yes? So, we subtract. Again, this is also subtract. So we get Sn minus rsn.
equals to
A now, right?
And then everything else cancels.
And this is negative.
ARN.
You know why it is negative, right?
Yes.
Yes.
Because it's 0 minus that. So here 1 minus r Sn. Here a bracket 1 minus rn. Yes? And finally our Sn will be a 1 minus r to power n divided by 1 minus r. Now we choose this when your common ratio is a fraction. Or when your common ratio is, no, this one is a fraction. Or when it is negative. Most of the time, just fraction. So that when you do 1 minus a fraction,
So it's fine.
so just to avoid negative. So the condition really is that this is used when the absolute value of your common ratio is more than 1. So if the common ratio is 2, 3, 4, you use the one with common ratio with r first. Of course, you get the same with this, but it's just like maybe the calculation might be a bit different, complicated. Yeah. So even if you have minus 2, it's okay. Use this. Okay? So for this one, this is used when the common ratio, the absolute value is less than 1. When I say absolute value, I mean, do you know what absolute value means? Absolute value of minus 2 is what?
2.
Absolute value of negative half is what?
Half.
Absolute value of 1 over 2 is what?
Still have one.
Still 1 over 2. Okay? So when we say absolute value is greater than 1, we're talking about something like this. Because the absolute value is greater than 1. So that's why I said we use this when it is a fraction. Like an improper fraction, actually. If your stuff is 3 over 2, which one is appropriate? Your r is 3 over 2, which one is appropriate? The first one. It still works with the second one as well. But we just write it differently. Now, let me tell you something that leads to this. We can add GPs. Questions like this will be done using these examples. We'll do examples together later. So, maybe Sonia puts 2 mop in a piggy bank, and every day Cecilia doubles the amount. Cecilia puts double the amount she put in the previous day. So which means on the first day Cecilia puts 2. On the second day, how much does she put?
4.
On the third day,
8.
on the fourth day, on the fifth day, and so on, right? 64 and so on. So the question might be, how much does Cecilia have after 5 days? Which means we are interested in S5. Up to here. It's easy to use calculator to do this, right? But what if Cecilia starts this operation in January 1st and she wants to do it for the rest of the year? Do you get my point?
Yes.
Are you going to add on your calculator? You press it 365 times 2, I think, because you have to press plus all the time. Right? Okay, minus 1, because you don't press plus for the last one. Do you get my point? So we use the GP. Now, this kind of series is a series when you have plus in between, right? I told you in arithmetic series. Sequence is just the number. Series is when you're adding it. This kind of series, compared to this series, tell me what the difference is. A tennis ball. Look, think of this. A tennis ball, while Kinlon and I were playing tennis ball, whenever we play, or maybe we just throw it from the height, maybe we're just messing around, COVID-19, we can't leave our apartment, we're on the top, and we just throw it down. Each time this tennis ball bounces, we realize that it bounces to half of the previous height. Which means if our apartment is 80 meters, the first bounce goes back to where? 40. The next bounce goes back to where? 20, and so on. We might be interested in after how many bounces it gets somewhere. That's like n time. But why do I bring out this sum? What do you notice about this sequence? 80, 40, 20, 10. What do you notice about it? I know. It multiplied by half. That's the common ratio half. But what can you say about how the number is going?
Decreasing.
It's decreasing.
But it doesn't give negative.
Yes, it doesn't become negative, but it keeps it decreasing. What about this one? It keeps increasing. Does this explain what is happening here in terms of the gap? Does this explain what happens here? It becomes bigger, right? It's like your flashlight or some of the light they use in maybe stadium or whatever. From the source, it's small. And as it goes further, what happens? It becomes bigger, right? And like in this case, it looks like it starts from somewhere here. Okay? Then it's becoming smaller and smaller and smaller. Right? This kind of series, we say it is a divergence series. It diverges. It explodes. It becomes big. You can't contain it anymore. COVID-19 started, it looks like it's diverging. But in some nations especially, they've been able to contain it. So it becomes smaller and smaller and smaller until you get it 0. Okay? So here, because it starts big, and we expect that it becomes so small, we don't know if it is 0. Okay? Or approximately 0. We say this converge. Okay? This kind of series or sequence, if I put plus it becomes series, is a convergence series or convergence sequence. Converge is the one that becomes smaller. It's converged at the point. So it's like that if you have like a light or whatever, so that it becomes small at the end point, then this point will be the point of convergence. Okay? When you have a convergent series, you can talk about something infinity. Again, when you have a convergent series, so take for example, I have 80 plus 40 plus 20 plus 10 5. 5 over 2, right? That's 2.5. 5 over 4. And somebody is interested in, if I keep adding this till infinity, what am I going to get? It's possible. Please. It's possible to find out. Because it's a convergent sequence or series. But that's not possible to stay here. Because it becomes bigger. So there's no way you can get the sum to infinity. The sum to infinity, in this case, is infinity itself. Because the number becomes bigger. But because this number becomes smaller, you can get the sum to infinity. That is the purpose of the second part. Only questions that are reasonable, please. Please don't slow me down. If you have a question, raise your hand. Yes, please.
Is it still called convergence and divergence for APs?
What do you mean?
Like if an AP increases, it's still called divergence.
The word divergent is not for AP or GP. It's for any sequence or series. But I'm trying to see, I don't think we can have something like that for AP. Convergence for AP. If your common difference is negative, the worst case scenario is your summation becomes minus infinity. Right? If you start with 5 and you have a common difference of say negative 10, the next one will be negative 5, negative 15, negative 25, right? So it becomes bigger even on the negative side. So we don't discuss convergence in a linear sequence, I mean like an AP. We discuss it here. Because we're interested in the number becoming smaller and we can see the pattern here. Okay? Now, does this make sense?
Yes.
Yes, Justin.
So you said this convergent series can go to
The addition
the
to
addition
infinity can be done.
Okay, but how can it be infinity? Because if it was a decimal form, then it would just be infinite decimal places, but would it actually go to infinity?
I'm coming to that now. Good question. You didn't know what he's asking? If you continue to add to infinity, how do you know the answer when you don't even know where to stop? Isn't that a good question? We are not talking about the final answer. We're talking about what is that point that the answer is getting close to. But as you continue to add infinitely, it doesn't get to it. So I'm going to introduce the word approaches. We say, what number does this addition approach? It doesn't get close to it. You will discuss some of these things in next year when you start discussing something on curve. Maybe I can share something with you on the WeChat group later. You can check online the Desmos app that we use for graph plotting. Have you used it in this class before? Desmos.com/calculator to do graph. Did we use it in this class?
We had a whole
Assignment on it. So we will do something on asymptotes. It doesn't touch, but it gets close to it. Have you seen a tangent graph before?
Yeah, I think so.
I think I mentioned it in tangent. So look at tan 90. It just, the curve goes close. It pretends it's touching 90, but never touches. Even when that line of 90 goes to infinity up, the graph pretend like, okay, I'm going to touch it, I'm going to touch it. But you keep on extending till y equals 10 million, it still doesn't touch 90. So in that case, we say the curve approaches 90. Do you get my point now? But it doesn't touch 90. Okay? All right. Why do I bring this up? Because we are interested in a convergence series. Can you tell me which of these formula, the sum formula, makes sense to discuss sum to infinity?
The second one.
Why do you say the second one?
Because you're minusing the.
There's nothing like minusing. Speak like a Form 4 student. Don't speak like a P6 student. Henceforth in this class. I'll tell you something. I was having a discussion with Mr. Lund yesterday. and I just needed to get his guidance. You can see I'm talking miss. I'll call you. I just needed to get the guidance about something that my Form 5 will be required to do, like a kind of paper, a research we need to do. And one of the things he's mentioned is, he showed me the criteria from ID, and one of them is communication. And these approaches that I'm talking about was one of the things he used as an example for me. So students should not say the number get close to 2. That to get a very good mark, you should use mathematical language. The number approaches 2. So, you know, I always say it like, oh, just this is not P6. Stop writing like P6. Stop thinking like P6. He mentioned that yesterday, and I was like, oh my God, I wish I could have recorded this and just showed my student what, you know, a more experienced person is telling me about this stuff. So it doesn't look like, oh, Mr. Daniel just brought these rules unnecessarily. Even writing formula. He said something about writing on the same line. And you know, I always say, can you write vertically? If I've had that discussion with you before, raise your hand. Something about, don't write on the same line. Like you have to break it down on different line. Raise your hand if I've mentioned that to you once at least. And he mentioned that yesterday. When he was telling me about, oh, IB will check the following criteria. One of them is communication. How you communicate mathematical, your essay in math. So students should not go about and link R minus 1, Sn, A, Rn minus 1, minus A equals, in the name of saving space. Every line should be different. So you can connect, oh, this previous line means you write something else, which means you write something else. So please, we need to be careful. And I don't want you to start struggling with that in Form 5. Okay? Yes, your question.
I'm just answering why you use it.
Well, okay. Because you are not really, you're saying something about minusing. I don't even know what that means. And we never had anything to do with minus in this case, so I don't know where you got that from. Yes?
Because it's just decreasing the number, the R must be smaller than 1 to make
The common ratio must be of this one. Because when we are talking about a convergent sequence, you can only have a convergent sequence when your common ratio is less than 1. Does that make sense? Common ratio is less than 1 is the case of fraction. So if the first term is 20, the second term will be 10. So it's dropping. And that happens only in this case. So which is why the formula for sum to infinity, we will bring it from here. Bring out the calculator, everybody. Are you there yet?
Yeah.
Sum to infinity of GB. What? Yeah. Are you there yet?
Yes.
Check this for me. Pick any common ratio. Okay, just pick a number that is a fraction. An improper, a proper fraction, sorry, not improper. I think I mentioned improper at first. That was an error, please. A proper fraction. Okay? So, I pick A over B, for example. That's my proper fraction. Put it in form of brackets, then power. Increase this power from time to time and tell me what happens to the answer when you increase this power. Do it for maybe 3 or 4 different powers. But each time make sure your new power is bigger than the other power. Make sure you have it in decimal. You can't do that here? Okay. Make sure you have it in decimal and notice something. Make sure you increase the power even up to 100, for example. And notice something. It gets close to what?
0.
0. It never touched it.
It doesn't get to 0, but it's moving close to 0. Am I making sense? Did everybody notice that?
Yeah.
Because I'm going to write something based on what you have just discovered with your calculator. Elsie, did you get that too? Elon? Okay. So, for sum to infinity, watch this. Since we have a convergence. Remember, this time around, the sequence or series must converge for us to talk about infinity. Okay? Since we have a convergent series, only when our common ratio, absolute value, of course, is less than 1, then from Sn equals a 1 minus r, this one. Okay. Say from Sn, a 1 minus r to the power n over 1 minus r. So I pick it from here. Okay? Please listen. Don't write. Please listen. As n becomes large, that's what this means. As n tends to, this is the symbol of tends to. Tends to means getting close to. Okay? It's not looking at the board. I give you your paper, you start writing. I'm explaining something, you're playing with something. What exactly is your problem, young man? As n tends to infinity, what that means is as n becomes so huge. Okay? As n tends to infinity, what happens? R to the power n tends to what?
0.
Say that louder.
0.
That's what you just investigated. As your n becomes big, your common ratio to power that big number always move close to 0. Do you agree with that? That's your investigation. Okay? So in that case, the sum in this situation is not something, it's not Sn anymore. It's sum to infinity, and that is the symbol, S infinity. So this implies that our S infinity will become a 1 minus 0 divided by, is this also 0?
No.
Yes or no?
No.
Why?
Because that's a fraction.
That's a fraction, not 0?
Yeah.
Why?
Because only Rn is 0.
Only Rn is 0, not R. This is just R. Does that make sense? So basically what I'm saying is, as n becomes large, your Sn also becomes S infinity. Definitely, right? We are not talking about the sum of 1 to 10 anymore. We are saying the sum to infinity. But we don't need to write it. So when n becomes large, Rn becomes 0, gets close to 0. Which means our sum to infinity, this formula, is now reducing to this. And finally, our sum to infinity is simply the first term divided by 1 minus common ratio. Let's test that. 2 plus 1 plus 0.5. Come on. That's a GP, right? With first term of 2. No, let's start with 4. Sorry. Start with 4, so it doesn't look like half and 2 are kind of similar, right? Start with 4. 4 plus 2 plus 1 over 2, which is 0.5. Plus 1 over 4. What's the next one after 1 over 4?
1 over.
1 over 8. 1 over 16, right? Add it up to any point of your choice. What do you have? Any point of your choice. It's sum to infinity. So only stop when you are tired of putting stuff on your calculator. Tell me what your answer is close to. Candy, what do you get?
6.9.
You got 6.9. Candy got 6.9. So that is very close to 7 or so. Yes, anyone else? 6.9 also. Where do you stop? She stopped at 1 over 128. Where do you stop, Candy?
1 over 64.
1 over 64. And both of you got 6.9 something. Yes, any other one? 6.9 also? Now, this is what has happened.
Maybe it is not 1.
4 plus 2 plus 1. I hope you added 1 to it. Check, please.
Oh.
You didn't add 1? So that should be 7.9.
Yeah, I got 7.
7.9.
Yeah, I got 7.
So which means that sum is close to what?
8.
8. So it means if you add infinitely,
Approaching.
you will just get something very close to 8. That's what sum to infinity means. If you continue to add infinite number of terms, Maybe you had 10 of them. Somebody decided to have 20 of them. I decided to have 100 of them. We cannot get 8. We'll get close to 8.